So this is a video about the future of chess training. So let's have some consideration of what that might look like. Here's a popular commercially available chess engine analyzing a position, and we can see that it gives a numeric evaluation to a particular position, which, if you think about it, that means it doesn't know. It's using generalized heuristics, and it's certainly not doing an exhaustive search, even though it looks through thousands of positions per second. So, what would a real search look like? Well, that would be like when you go to a table base. Let's look at one of those. Let's go. This is a so-called Nalimov endgame table base, where you can set up a position and set up the board. Trying to move this up here. And when you set up the table base and you set up a position, it's not going to tell you plus 2.5 or anything like that. It's going to tell you exactly how many moves it takes to checkmate with best play by both sides. So here we have white to move. This is a forced checkmate in no more than 23 moves. As you can see, and we could expect this to be the case in more than one example, not just endgames but middle game positions, there are several moves that are equal in the sense that the number of moves required to checkmate are the same. See, all of these are 24. The top two are 23. There's often not one single best move. But the point is here is this is the only actual evaluation, a real complete evaluation. Either there's a checkmate in a certain number of moves, or there's not, in which case it's a draw. So when you look at an engine working, and we see, even if I change engines here, change to a different engine, you're going to see that still it just gives a numeric evaluation, which a lot of the people watching this are familiar with. So here's Fritz 16, the commercially available engine, and this engine will beat any human in the world. Any of the top human grandmasters would lose a match to this software that anybody can buy and put on their computer. So it kind of leads to a question that I want to consider in this video is, what will training look like for the world's elite and for amateur level players if we knew the best move or best moves in any given position? And why would we? Let's take a look at something here. That was an endgame table base, and now a 6-man endgame table base takes up 1.2 terabytes. Those were finished in 2005, and you can fit those on your computer. The 5-man endgame table base, which is more than any human could ever be expected to memorize, takes up 7 gigabytes. The 6-man 1.2. The 7-man endgame table bases, which have finally been finished in 2018, take up 140 terabytes, which is a bit of a challenge for a lot of home computers. The 8-man would take up at least 2 petabytes. A petabyte is a quadrillion bytes, 1,000 terabytes. Terabyte is 1,000 gigabytes. So they're getting bigger by a factor of normally about 100 each. This one's a bit less than that. But each time you add 1 man to the table base, it takes many years and ends up with a table base that's a whole lot larger. So if we had a 32-man endgame table base, which right now is our only sure path to an absolutely solved game, what would be the effect on practical play? So consider this. If we had a 32-man endgame table base, you could take any position that could occur, and we would know with certainty what the best moves were. So there's a couple main possibilities. The one I think is most unlikely is that black is winning. Maybe it's possible that white is winning, but we believe that the game of chess is a draw. So let's suppose it is. Then if you could pull up any position and know what the best move was, would every single game between grandmasters be a draw? Can you think of a strategy somebody might use successfully against a human being who's playing another human being? You probably have thought of it. You deliberately play a move that's second best, but still not bad, and also one which contains some tricks and traps into it that the person playing the move has become familiar with conventional computers and play with other strong humans. So that move could be practically employed and could even win a game. Sure enough, after the game, somebody would discover that the person who lost made a mistake. That's why they lost. But it would not be the case that every single move, even if there was only one best move in every position, which we know that's not true, but even if there was just one, would everybody just play the single best move all the way to the end of the game and make a draw every time? I don't think so. I think they would want to try to win. So let's suppose, for example, that we found out that if you play the move e4 on the first move, black has a forced mate and 185 moves. But if you play d4 on the first move, you have a draw. So if everybody just played best moves, black would only prepare against d4. There's a bit of a poker game going on there. So you play e4 knowing that it's quote-unquote inferior, and then you challenge black to find the mate in 185 over the board, because it would take more than 10 lifetimes for the computer or whatever system to even show that to a person with all the ifs in there. So yeah, it would certainly have a practical impact on grandmaster play. However, it wouldn't be just a matter of memorizing moves even then, because there would be an invested interest, especially if it turns out, which is most likely, that the game is a draw with best play on both sides, that people would try to find second, third, or even fourth best moves that presented practical difficulties to their opponent. So I don't buy the idea that computers would ruin chess, and I don't buy the idea that artificial intelligence will ruin it. In fact, the appearance of AlphaZero enriched our study of openings. I noticed that Magnus Carlsen was playing d3 in the Rui early, uh, before the match where we saw AlphaZero doing that. And even at Grandmaster level, there is some value to deliberately playing a single or two or three second best moves to get to a position that has practical difficulties that the opponent might not have anticipated. So how will artificial intelligence weigh into this? Well, so far you can kind of see a timeline, and before artificial intelligence there was something called Moore's Law, where computing speed was supposed to double every 18 months. Well, if doubling the speed meant that we could come up with a database that's bigger but faster per position, then it would still take till the 24th century before we had a 32-man endgame table base. But now with artificial intelligence to help us, who knows, we may have a complete solution to chess in the next 20 years, or maybe less. Some of you have probably heard of the Turk. That's where they hid a person inside of a box and claimed that it was an automaton, and then it was discovered. But the first time that machinery became the strongest chess entity, or proved it anyway, was in February of 1996 through May 11th, 1997, when Deep Blue beat Garry Kasparov. So we can assume that it had a rating of a bit higher than 2,900 then. Now you can get Stockfish sometimes for free, and it has a staggering 3925 equivalent rating. I remember back in 1980 when people used to buy like the Fidelity Excellence, which was a tabletop dedicated chess computer, and it's at the highest level it would only play at like expert level. A human who wasn't even a master could occasionally beat it, even though it was better than about 98% of hobby players. But as of the 21st century, computer engines could really be relied on by even by the world's best players, even the software that you could just buy and put on your computer. But in December of 2017, something totally game-changing took place. Before then, computer programs were fed in openings, told what openings to play, told how to think, and told how to evaluate positions, and all the processing was done by a single conventional processor in serial fashion. Well, when AlphaZero came along with its neural net and all sorts of learning going on, it was simply told the rules of chess, and then it was set to play games against itself. That was an AI program developed by DeepMind for Google. After 4 hours of self-training, they put it in a 100-game match against the strongest computer engine that we had, which at that time was Stockfish. In a 100-game match, AlphaZero won 28 times and never lost. So there's 72 draws for a final score of 64-36. So AlphaZero won the 100-game match without having a single defeat. So now it's really not unreasonable to think that AI might eventually solve chess in the next 20 years. So what would that do to chess training? I think a lot of people would be tempted to study openings way too much, and what's going to happen is they're going to play up to the 10th move perfectly more often, and then just like before that period in time, both sides will make huge tactical errors through the rest of the game, and the eventual winner will have almost nothing to do with the opening. If they get to an endgame, it's unlikely that they're going to get to an endgame that's simple enough to be in a table base where they would not already have been able to know what to do. So I invite you to disagree with any or all of what I've said here, and I'm certainly interested in criticism and your opinion. So you tell me, I am Chris at chrischess.com. So that's how you can communicate with me. You can leave your comments here. Do subscribe and like this video, and I'll see you in the next one.